microphone is right there. And what else? My phone here is fine. And you have to look at stream health. Look at the stream health. Stream health and 2 people here. And what else are that one, right? It's one of the yeah, but we have already discussed it. This one, right? You have to let it go and yeah. Why? Anyone else? You should go right now. Yeah. And this one, right? What is that? Oh, this one. Left screen. Left screen should be there. Yeah. Left screen. Okay. Okay. Right there. Camera is alright. Okay. What else? Nothing alright. And to this machine we are gonna observe the sound from YouTube, from Zoom, right? I'm gonna see the Zoom on this one. Nothing now, no. Timing. Okay. Video by trade. Hochslassig bound. Okay, test 1, 2, 3. Okay, เสียงไปนะครับ and what else? It's nothing. Okay. And มีพิมพ์เริ่มพิมพ์ชื่อมาเลยได้เลยนะครับ and we're gonna throw away the file, right? โยน โยนไฟล์it's EE111 นะครับน่าจะ1425ครับที่เราจะเริ่มกัน EE111 EE111 this to I this one and here and we throw it to add up to iPad. Right. Okay. Data to EE111 here. First chapter section. Okay. And open. ประมาณนี้new important file SWU lecture and EE111 chapter 1 where is that เรียงตามอะไร PDFไฟล์ไปไหนแล้วไฟล์ไปไหนแล้วเอาใหม่ iPad throw it here to this one. Oh my god ไปแล้วdata yes iPadมาที่ iPadทำไมไม่ไปโอเค data EE111 to the first light plane section assessing. Okay, finish, get back, import. Here, right, okay. It comes now, okay. Today is 20, right? B03 and 20.01.2022. Enter. Okay, in on the left hand side, light plane, this one. Okay. สวัสดีครับ Good afternoon, everyone. I'm sorry for that being late. 14:30 is the actual time we are gonna start our classroom, right? It's EE111. Oh no, it's B07. I'm sorry for that. B03 is valid for EE292. I'm sorry for that. It's B07. Yes. Okay. Good afternoon. Officially, welcome you to EE111. Everything needs to be spoken in English, right? Because this is the section for logistics, right? So let's take a look at you in Zoom, right? We start from Cartesian Coordinate, okay? No, we start from ธัญนันท์ ณัฐกิจ วรัญญา ศศิการ ทิติพงษ์ เมธาวี อภิศรา and ภาคีน คานชนก สถิตา พิชยพงษ์ Phakhanan Arisa. I'm sorry for being late today because I was just informed by the authority of our faculty that today there will be the vaccine campaign offered by the faculty of medicine. So yes, you just made the same way as usual. If you can't remember your number, you may take a look at this. It's first lecture, right? I have sent you the class attendance scorelets. Here your name list. Please follow from this one, right? Where's the mouse? Okay. The number one is Srinakharinwirot. Okay. The second is Phakhawan and blah blah blah. And you can also go to several YouTube's link if you want. Okay. For example, I'm gonna send you the link in Zoom. Here is EE111 live group. Sorry for that. Here, wait. This one นะครับเดี๋ยวส่งลิงก์ให้ที่ไลน์กลุ่มนะครับว่ามี YouTube ที่ใดบ้างนะถ้าคุณ sometimes the sound in YouTube or the video quality in YouTube is better. You may follow that. Okay. In the second one, right? This one and also this one. Okay. Okay. Here. Yeah. Natapon has written her name on a YouTube channel. It's fine. I can see it. And where else? There's nothing more. This channel, right? You may go to. Oh no, this one. Okay. Here you have your channel, and yes, there is another live from this one too, right? And how could we send it? Okay, anyway, this one. Okay, yes, you just send it to here. Send the link. Okay, and then you get the link from this one. Now, you can go to any channel. It's up to you. Oh, sorry. ผมเปิดแล้วเสียงสะท้อนครับ you can go to the link any channel as you want. Moment. Mail. Okay. Gmail. Yeah. Parametric. ซาซิตามาก่อนเลยนะครับ Okay. Yeah. Let me get the message. Okay, this one too, right? This one is also valid. It's wherever you want, okay? But at least you should have your name once, right there. Oh no, not this one. Here. This link is. Oh no ผมไป เปิดเสียงเขาอ้าวเดี๋ยวเสียงมาอย่างไรOkay, stop. Not on. No, not this channel. I mean, another channel. Okay, this channel. Copy it and send it through this one. Okay, and look at this. Okay, this one. Okay. Okay, this one. Okay, มีทั้งหมด4ช่องนะครับพยายามอัดไว้ให้นะครับเพราะว่าจะมีคนเรียนซัมเมอร์ด้วยนะครับโอเคก็จะได้ให้เขาดูไปเลยครับโอเคnow let's talk about our story. I'm going to one or two more people have written his or her name, right? วิสาขาวิธิตาครับโอเคI'm gonna share the screen and we will start our lecture right now. Yes, it's time for us to officially start after several electronic problems. Right? I hope that you could hear well in the YouTube. Yes, today is 20, right? We're gonna officially start the first chapter. The first chapter is something about line, plane, surface. Okay, three quantities in three-dimensional system, right? Yeah. Oh, I'm sorry for that. I need to close the lamp. Okay, yeah, 2, 3 messages more. All right. If you have any question, just let me know immediately. All right, so that we can keep communication. If you are unclear to something, just let me know. Okay, three quantities, line, plane, and surface in three-dimensional space. Okay, 1, 2, 3 things. And three-dimensional space mean you have three axes, right? The first axis you have learned, okay, 1D. Sorry for that. Okay, 1D. One-dimensional system is that you have only the x-axis, right? 2D means you have y and this is the y-axis and this is the x-axis, right? This is what you may have seen during your high school or even in the first year of bachelor degree here. And the third one is 3D, which is what we are talking here in this subject. This is the z-axis, okay? This is the y-axis, and here is the x-axis, okay? How could we remember? Okay, you know ถ้าใครดูที่ Steam Lab นะก็จะมีรูปมือให้ด้วยนะโอเคไหมif you look at the Streamlab channel you can see my hand, but if you look at Zoom or Zoom to YouTube channel you may not see my hand. Okay, the way to memorize the x here, x axis here and y axis here and z axis here is that okay, I need to use the mouse. X axis here and y axis here and z axis, right? You start from your 4 fingers along the x axis. Okay, you use your right hand. Okay, ทุกคนมีมือขวานะครับ I hope that everyone has your own right hand. Okay, x to y, right? X to y, and then z is the thumb direction toward the camera in the Streamlabs, okay? Or if you look at the OBS channel, you can see a little bit my hand, okay? Yeah, that's the thing you may, the way to memorize the, it's better if I draw, okay? This is your forefinger, okay? And this is your thumb, or this is your hand, this is your right hand, right hand, and your curve, you rotate your forefingers, okay, start from x to y, and this direction is going to be the z direction, okay? If for the people who did not join, who didn't watch the Streamlabs channel, okay, again, in Streamlabs channel, this is my hand, right? X, Y, and Z. And that's why we have X to Y and Z. This is the way to memorize how we have 3 axes, okay? Okay, let's go further. Yes, everything, I would say 70% of this subject will talk about the 3-dimensional space, which means the Cartesian, mainly Cartesian Coordinate System that has 3 axes, the x-axis, the y-axis, and the z-axis. All right. Okay. Yes. ทุกที่สัญญาณดีนะครับเสียงใช้ได้นะซูมถ้าไม่ได้ยินแจ้งผมทันทีนะครับ Okay. I'm also monitor you in this channel too. What else? Now we will talk about the content in this chapter. The first thing is Euclidean system. Okay, Euclidean system is the system that is based on the Euclid idea, but it's valid for general system. Okay, most systems rely on this. All right. The next one is the Cartesian and rectangular coordinate system. So it's this one. Okay, is what you have seen here. This is the z-axis. This is the y-axis, and here is the x-axis. Okay, the first one, number 1 is here. The number 2 is here, and the third axis is over there. Cartesian coordinate means you have a coordinate of x, y, and z. Okay, that's the Cartesian coordinate. And is there anything else other than Cartesian coordinate? Yes, of course, there are 2 more coordinate systems. The first one is cylindrical system, right? You will see it later, but if you want to hear what is that, it means you have a cylinder like this, and you have the x, y, and z like this. But we are going to talk about the any point measured to the origin, the original coordinate, and we project it like this, and we measure it like this. Okay, that's the cylindrical system. Let me write down cylindrical. You will see it later, but not in this system. Okay, cylindrical system. It's based on cylinder, right? And another one is the sphere system, right? Spherical system. It's 3-dimensional too. It's x, y, and z. That's our spherical coordinate system. The spherical coordinate system. This one too, right? Coordinate. Spherical coordinate system. Okay, that's the 2 more coordinate system. The first one is cylindrical coordinate. The second one, the third one is the spherical coordinate system. The first one is here, which has only x, y, and z, and It's known as Cartesian Coordinate or Rectangular Coordinate System. Okay, all right. The first thing in this chapter, we will talk about the line, how we construct the line. You know line, right? Okay, line could be anything like this, line, but it's not straight line. Okay, this is freedom. That's the general line, but for us, we are going to talk about the straight line. Okay, this is the straight line. Straight line, and the next one is we will construct the plane. Okay, what is plane? Plane is a surface that is smooth. Okay, this is plane. This is known as plane. Okay, this is line. This is random line. This is straight line. This is plane. And what is the surface? Surface is something that is bending or something like that. Okay, here is surface, and this one is known as surface. Okay, it's like your skin or any curvature. Okay, that is not smooth, that is not planar. It's got to be called surface. Okay, it's smooth. For example, you see the shape of this bottom, so it's a surface. Okay, and the plane is like the monitor of this iPad. Okay, of this iPad, it's plane. All right. The third thing we will talk about is the distance between a point and a plane. You know the plane, you know the line, you know the smallest one is point. Okay, point has no dimension at all. And if you have the plane like that, in you're gonna measure the distance between this one and it's going to be rectangle right there, and you use anything to measure the distance here. So what is d at this situation? That's the problem. We will talk about distance between a point, this one point, and a plane here. Okay, this is point, and here is plane. Okay, the distance between a point and a plane. We are going to talk about the distance here in this topic. The next one is the intersection of two planes. Okay, you know there is a plane, and plane is smooth, is planar. But what happens if you have another kind of, what happens if you have another plane like this, okay, and you move it to be here to touch this one, okay, there will be intersection, okay, and some of the intersection may happen, some of the intersection may not happen. Okay, it depends on the situation. Anyway, yeah. นะครับก็ที่ซูมนะครับก็เข้ามาเช็คชื่อแล้วจะอยู่ที่ซูมก็ได้หรือไม่เข้ามาซูมเลยก็ได้นะครับไปที่ YouTube แล้วก็พิมพ์ชื่อที่ YouTube เลยก็ได้นะครับเพราะว่าผมก็สังเกตการอยู่ตลอดเวลานะครับ alright anything else yeah, in the Zoom to YouTube channel there are two people, Switch การเจริญ and ค่าเจริญนะครับ Switch ค่าเจริญชนพร and in OBSNo2 YouTube there is here we have Nakhon, right? Okay, and what else? Yeah, that's the content of this chapter, and the next one is the Euclidean System. So who is Euclid? Let's go to some internet. Who is Euclid? Oh no. Euclid. Oh no. Euclid. Okay, maybe this one. Okay. Euclid is a philosopher in Greek ancient time. He is a mathematician. Okay, he works in mathematics, and yeah, his name in Greek is he's known in English as Euclid, but his actual name in Greek is Euclides. Okay, Euclides. During this year in a very ancient time. Okay, he's because at that time there was no camera at all. The people memorized someone by using by drawing. Okay, he's the character. So that's Euclid, and we are based on his idea. Euclidean is an adjective derived from the name of an ancient Greek mathematician. His name is Euclid or Euclides. Okay, Euclides in his actual language. Okay, the next one is that in Euclidean there are five Euclid's postulates. So there are five some basic facts. Okay, basic facts about Euclidean. The first one is that a straight line segment can be drawn by joining any two points. Oh, it's very simple. Okay, the first one, if you have two points like this and you just join it by using a straight line, so you get a straight line segment. Okay, which is a part of the whole line. Okay, the whole line might be, you can extend it further. Okay, you can extend it further, but this one is known as segment, only a part of the whole line. Okay, it's known as segment. I'm sorry for that. It's known as segment right here. Okay, the next one is any straight line segment can be extended indefinitely in a straight line. Of course, right here, you can extend it. Okay, I remove it. Okay, the second one, once you have the segment like this, okay, that's the original form, the first step. You can extend it in infinity. Okay, to the right hand side. You can extend also to the left hand side, infinity. Okay, that's the second postulate by Euclid. Given any, the third one, given any straight line segment, a circle can be drawn having a segment as radius, one endpoint as center. Or it's nothing. It's like you use the device here. If you keep this one as a center and you try to rotate, right? You try to rotate, you're gonna get the circle. Okay, it's nothing. For our right angle are congruent. What is that? Congruent. Congruent means having the same side and shape. Of course, the right angle, you know, right? Right angle is the angle that could be measured in this direction, and it's valid for 90 degrees. And of course, in wherever position, the right angle will be the same, whether you express it like that or in this direction. Okay, all have the all these right angle have the same size and shape. Okay, because it's aligned with 90 degrees to each other. The fifth one, if two lines are drawn which intersect a third in such a way that some of the inner angles on one side is less than two right angles, then two lines must intersect each other. It's quite complicated, but you could understand easily like this. If you have two lines and if you have two lines like this, okay, two lines like this is the first. This is the first line. This is the second line. This is the second line, and you draw a line to both to these two lines. You just draw it, okay? And let's say the angle here and the angle here. Oh, sorry, we use a different color. Okay, the angle here and the angle here, and we have also another direction, which is this one. Let's say this one, the blue one. Okay, the blue one could be, for example, alpha, beta, and the red one is A and B. Okay, Greek and English letters. If A plus B is greater or less than, okay, in this case, A plus B is greater than alpha plus beta, it means that the two lines will intersect each other, will touch each other or intersect. Okay, there will be will intersect each other. You understand that? You may not see the intersection, but if you project this one further, it's gonna touch it somehow. Okay, so once the two lines touch each other, we say there is intersection between those two lines. Okay, that's the fifth postulate by Euclid. This one. Okay, it's not too difficult to understand. That's the fifth postulate. Okay. The 5 basic things in the Euclidean system. Okay, if any system that follow these 5 basic things, we would say that system is Euclidean system. Okay, all right. And what else? Euclidean system is a system in which all the usual rules of Euclidean geometry hold. This is the 5 basic geometry rules by Euclid. And now it's difficult to realize, right? But we have to know that, because this is the introduction to Euclidean system, the system that has these 5 rules. Okay, it might be very, very fundamental or very basic at the beginning to us, right? Yeah, we will see it later in the next one. In two-dimensional system, the Euclidean plane, it's Euclidean, but it's 2D, right? As I told you at the beginning, the 2D means this one. Okay, you have x and y, and for us on this page, two-dimensional system means the Euclidean plane R2 has the 2 perpendicular coordinate axes, which are x-axis, this one, x-axis, and y-axis, this one. Okay, this is the 2D system, right? You have ever seen during your high school, right? ทำไมมันร้อนอย่างนี้ครับ ขออนุญาตลดอุณหภูมิแอร์นิดนึงครับ Okay, that's the two-dimensional system in Euclidean, right? You may have ever seen the 2D system since you were in I don't know, in the high school or something like that. Yeah, we will. Okay, let me monitor you again whether the audio works fine or not. Yeah, test 1, 2, 3. Okay. The next one is the Cartesian or rectangular coordinate system. Okay, we arrive at this section. Okay, this topic, Cartesian and rectangular coordinate system. For a function of single variable, you know single variable, right? Single mean number 1. Single mean you have no girlfriend, no boyfriend or something. Single means you are only one, right? Single variable function means you have like fx, it's called also single variable function. You have rt, okay, rt is t squared, for example, fx is 4x. That's the single variable. If you have fy, which is y square minus 2y, it's also a single variable. What else? If you have xs, okay, which is 1 by 3 s minus 5, okay, that's also a single variable function here, okay. So a single variable function is a function that has only a single variable. A graph of f function here is given by the point coordinate x, y, okay. If you have here x and y, right, and y is fx, okay, y here is known also as fx, okay, this one, if x is equal to y, the coordinate x and y could be also expressed as the input value x and the output is the function fx. And the point x, y equal f x, comma fx lies in the Euclidean plane. It means this point, you know the point, right? Point x, y. For example, the point 4, 3. Where is that? It means you go along this 1, 2, 3, 4, and you go along y-axis 1 by 2, 3. Okay, you project it. Okay, and here is the coordinate 4, 3. Okay, that's the point 4, 3. This is what you may have ever seen during your high school, right? ทุกคนน่าจะเคยเห็นในช่วงมปลายครับ Okay, and the next one is that this one because x is a member of the real system and y is a member of the real number set, so x and y will be the member of R2 because this is R2 means you have R cross R, okay, the set, the combination of two sets, okay, because x is a member of real value set, y is a member of another real value set, and for the multiple for the combination of these two things, two quantities, it's going to be the member of R2 like that, okay. And that's the two-dimensional system, okay. We remind ourselves for this situation because this might be the case you have ever seen. You may have experienced it before during your high school or in the first year of bachelor degree or in the last semester. And because everything in reality should have 3 dimensions, right? Everything is in 3D or even 4D will expect to time. Okay, the next one is the Cartesian, the XY plane. What is XY? In 3-dimensional system, right? Now we are considering 3-dimensional system, 3D. 3D is this one, okay? 3D means you have 3 axes, right? X, Y, and Z. And let's go further. And here you have the plane, and it's known as XY plane. What is the reason why we call this plane as XY? Look it as the table, the table tennis, okay, and the table for table tennis, something like that, or your table, okay. The surface of your table is gonna be known as plane. And what is the reason why we call this one as XY plane? Because this plane lie on x-axis and y-axis, okay. It lies in the same way as x-axis and corresponding to y-axis too, okay. This is called XY plane, okay. What is the general expression? It means z equal to 0, okay. When z is equal to 0, it means we have XY plane, okay. We have XY plane. Let's move to the next plane. Here is another, okay. We still have here 3-dimensional system, right? 3D system. You have x-axis, y-axis, and z-axis, and the plane right here is over there, right? And this is known as Whiteside Plane that includes y and z. Okay, y and z plane right here is known as Whiteside Plane. What is the description of the Whiteside Plane? It means that you have f, which depends on x, y. No. The Whiteside Plane means that you have x equal to 0. Okay. The variable that doesn't appear in the name, in the title of xy plane is the variable z, and the xy plane means z equal to 0. The variable that doesn't appear in the name of this plane is x, right? So x is equal to 0, and we call Whiteside Plane. And this one is known as xy plane. The variable that doesn't happen, doesn't exist in the plane name is the variable y. So this one means y is equal to 0. Okay, this is the xy plane because it lies along the x-axis, lies along the z-axis, x and z plane. Okay, it corresponds to the x-axis and the z-axis. It's known as xy plane. All right, but it has no value along the y-axis at all. This one has no value along the x or negative x at all, so x is 0. And this one has no value for z at all because it exactly is z equal to 0. Okay, you got to know already 3 fundamental planes in the 3-dimensional system, Cartesian or rectangular coordinate system, right? The first plane, which is quite easy, z equal to 0, is known as xy plane. The second one is x equal to 0, and we call this plane as y-z plane because y can be positive and negative, and z can be positive and z can be negative. The third one, the last one in the simplest plane, right, is the xy plane. The xy plane means there is no value for y at all, positive y and negative y. No, because y is equal to 0. Okay. Cartesian Coordinate System or 3D system could be represented by this cubic. Okay, it's basic rectangle 3-dimensional system, right? And the way to express the function is that we want to observe the value along the z-axis in terms of variable x and variable y. So you have to input 2 things, x and y. Okay, what value along the x and along the y, and you will get the height along the z-axis, and that's the meaning of this notation. And coordinate means you have value. You need to have at least one value for x, one value for y, 2 things you need to know, and after that you will get z value from every x, y. Okay, you just input x, insert the value of y into this function. Okay. If you cannot remember, if you don't completely understand, let me take an example. Let me bring you to an example. For example, if z is equal to fxy, and fy is what is that? 2x minus 3y. For example, if you want to know what is the set variance. If you want to know z, you need to give at least 2 things, which is the coordinate x and y. You need to deliver this one to the function. You will get the value for z. For example, if you want to observe this function when x is equal to 1, okay, when x is equal to 1 and y is equal to minus 1, what is the outcome from this function? So you could say that f1 and y minus 1 will be 2, 1 minus 3 and number 1, not minus 1 here. So you have 2 and plus 3 is going to be 5. Okay, and that's the way we have a function with two variables and it's equal to z. Okay, this is the way in Cartesian or rectangular coordinate system. Okay, the point is given by x, y, z, three things. For example, the point here you have got here could be written as you know that x is 1, right? X is 1, so we write down 1, and y is -1, so we write down comma and -1. And the next thing is the z variable, which is number 5. We are going to write down here number 5, and this is known as x, y, and z equal to 1, -1, 5. All right. Yeah, this is the way of the point you could generate from this function. You can choose any x and any y, but your z is going to be changed also. All right. The 3D system in Euclidean could be written as a member of the set R3. What is R3? R3 means you have R cross R. This is known as R3. Okay, because the way you write here is too long. Okay, it's the full expression, but we would rather express it in a simple way. Okay, otherwise we will get tired by writing so many things. So this is the short notation for the product of these three sets, real value set. Okay, the next thing in this subject is that you need to know the basic notation. Three quantities, okay, the three quantities in linear algebra. The first one is scalar. What is that? Scalar is like scalar is number 1. Number 0.75, number minus 2.649. Okay, that's scalar. And vector, what is vector? Vector is the quantity that has direction. For example, you have vector of 1, 3, 4. That's a vector. And you have vector like 0, 4, -1, 5. That's also a vector. Okay. Or you can also say vector with direction. Okay. And the next one is matrix. You know matrix, right? But we would not talk about matrix so much in this subject in EE111. Matrix is like 1, 2, 4, -5. Okay, that's a kind of matrix. Or you can even have a very long matrix like 1, 2, 3, 4, and 7, 8, 6, 5. That's also a kind of matrix, right? Oh, where is that? Okay, and the way to observe whether it's scalar, vector, or matrix is the following. Well, light phase means it's light. Okay, both phase means it's straight. Okay, with a little bit more dark. Okay, darker than the light phase. Lowercase is the lower letter, right? And uppercase is the upper letter. For example, lowercase of A is written here. Uppercase of the letter is written here. Or Z, okay, light phase of Z is, lowercase of Z is this one. And uppercase of Z is this one, right? The capitalized font. And scalar can be either R or complex. Okay. Whether you use uppercase or lowercase, without the boldface font, we are gonna say it is a scalar. Okay, this is also scalar. This is another scalar. Whether it's real or complex, it's known as scalar. But for vector, we are gonna use the straight line like this. Okay, if you can't differentiate. A here is in the light phase, this is in the bold phase. It's straight, more straight, and this is vector. if you don't completely understand, take a look at this. This is 1 times 1, it's scalar. This is m times 1 because you have, for example, 1, 2, 3. You have 3 quantities here for the vector. M is 3. And vector that has a straight line like this, the both-face form like this, you would have also the complex value. We can also use the Greek letter to represent this, okay? And the lower form or the lowercase of Greek is denoted by the vector here. And for the uppercase, you could see the difference. Okay, this is the lower face, right? The light face. This is the light face version. This is the bold face version. Okay, it's more stretched. And yeah, this is scalar. This is matrix. Why we say matrix? Because the dimension is m times n. For example, this matrix is 2 times 4 because the number of rows is 2, the number of columns is 4, so it's 2 times 4. Okay, and we can also use the Greek letter to represent the matrix. And once we have the complex data, it could be also the member of the complex set like this. Okay, now let's move to the next section. We have finished the topic of Cartesian or rectangular coordinate system, right? I have introduced you to that. We start the next topic, which is line through a point and parallel to a vector. So there are 3 things. The first thing is line. The second thing is point. The third one is vector. So there are 3 things you have to keep in mind. We are going to construct a line from the knowledge of point and vector. So we know a point like this. Oh, sorry. Yeah, we know a point. We know a point and we know a vector. And we want to construct the line. We are build up the line. We're going to find a line from point and vector. So line like that. Okay. Let P be the point in the Cartesian coordinate. You could see that P has 3 things: x0, y0, z0. That's the point in the coordinate system. Let's say you have an empty paper right here, and I draw something like this. This is the z-axis. This is the y-axis. This is the x-axis. And if you have the point P, which is let's say P is over here. P has coordinate. x0, y0, and z0. Okay, any location. What does that mean? It means if you project it to the xy plane and you measure it like that, and you measure it like that. The distance here is known as x0. The distance right there is known as, oh, I'm sorry for that. This is stupid. This is y0, and here is x0, and the height here is known as z0. Okay, that's the point P. P has value along the x-axis, value along the y-axis by y0, along the z-axis. This is the upward direction, right? So we build this one up. We put this one up by z0. It's called point P x0, y0, z0. Okay, now we have another thing, which is we know the point P, we know vector. Vector is denoted by this notation. Okay, we use the parenthesis, the angle parenthesis on the left and parenthesis along the right. Vector ABC means the vector ABC means you have coordinates like this. It's known as A, B, C, and the vector ABC is this one. Vector V is this one. Okay, the vector that point to the location, the point ABC. This is vector V. Okay, this is vector V. So in conclusion, we know two things. We know P, we know V. Okay, and the question is construct the line that passes point P and parallel to the vector V. Okay, vector V is over there. Okay, we cannot touch vector V, but we are gonna build up a line. We build up a straight line, but in the green one, in the black one, like here. We are gonna build up. Of course, our hand is right there. We're gonna build up a line. Okay, that passes. Okay, you could see that the line, the black line here, the straight line. The straight line passes the point P, and the straight line, of course, there are many lines that pass P. Okay, in this direction, the line in this direction will also pass the P. But we are interested in the line that is parallel to the vector V2. Okay, we need to be parallel to vector V2. So that's why we have only a single line here. Okay, it's parallel to this one and it passes the point P. So this is the story about this topic. So in order to find a line, we need the vector L, and vector L is equal to vector R plus T vector V, or many things. What is that? So the meaning is the following. R is a vector pointing to the vector P. Okay, what is vector R? In conclusion, the vector R is something like this. Which color should I use? Oh, this one. Okay. Okay, vector R is this vector that pass to point P. This is vector R. This is vector R. Okay. And if you want to construct vector L, what is vector L? Vector L is this one. Here, this is vector L. Vector L might be longer than the line. Okay, that's vector L, and here is vector R, here is vector V. So if you want to find vector L, you just make the summation between vector R and anything that scale vector V. So in this case, vector L is equal to vector V plus, oh sorry, R plus TV. I'm stupid. Where is R? Okay, R with that color. L is R plus T and vector V. Okay, R plus T times V. Okay, that's the way to find the vector L. Okay, I will not give you any proof. Okay, you just go to the book and read it. Okay, and that's the vector L. The solution to this one. Okay, so L will be equal to R plus TV, and T. What is T then? T is any scaling value. T could be picked up from any real, this is the real axis, real value. Okay, the set of real number, real value set. Okay, this is the real value set. This is a plus. If you go to the right, it's more the plus, right? X is positive. X increases. Okay, T increases. T could be taken from this one. Okay, pick up any value from this axis. It's always all the time valid for T. Okay, T could be any value on the x-axis. So in mathematics, we're gonna say T is a member of the set from infinity to infinity. Okay, that's the value for T. I is the vector pointing to point P. You just start from the origin and go to the point P, and that's known as vector R. All right. Now, and the solution for this is going to be, the solution for this one is, you know that vector V passes the point ABC, right? Point ABC, and vector P passes the point x0, y0, z0, and T is any value. And the set of straight line, because we are talking about the line, the set of the line is the set of several points, right? So the line set could be the set of coordinate x, y, z, given x is equal to x0 plus at, and y is equal to y0 plus bt, and z is equal to z0 plus ct, like this. Okay, and you could see, you could get the line from this one. Okay, and we need to also provide the information of the variable T, because T is the additional thing. So we would say T is a member of from minus infinity to infinity. Okay, and that's the closing set. Okay, yes, that's the line set. And now we will talk about the first example for constructing the line from the point P and vector V in a vector form. Okay, we are going to talk about the construction of the line L through point P and parallel to vector V. So you know two things, right? The point P เราเริ่มเท่าไหร่นะ14:25 ใช่ป่ะจบ 17:25 ก็ประมาณอีก2 ชั่วโมงนะครับโอเค 1 hour has already gone, right? has gone by. All right, the next one is the construction of the line set, the line set L from the point P and the vector V, right? Yes, the way to do that is the following. You just go to the expression number 6 here. L is equal to R plus TV, and what else? Just go to that and construct it. All right, build it up. L is over there. Yes, you know that the basic formula is the following. L is equal to R plus TV, right? So in order to find the set L, we need to construct first the vector L, and before we substitute this, we need to know what is the vector R, right? So from the question here, vector R is the vector that passes, that has destination of the point P. So vector R will be this one, 2, 3, 5, but we don't use the circle or the curvature parenthesis. We're going to use the angle parenthesis. So vector R is 2, 3, 5. Okay, and vector V, of course, vector V is what they have provided here. It is equal to 4, -1, and 6. All right. So in order to find the vector L, you just substitute this into this expression. You're gonna get what is that? It's vector L, right? Vector L equal to vector R, which is 2, 3, 5, plus T and 4, -1 and 6, like that. And yes, the way to combine everything here is the following. This is the first element. This is the second element, the third element. First element of the vector system, the second element of the vector system, the third element of the vector system. The way to do is you have to, of course, you know that the multiplication operator has higher priority. You have to do it before, right? So we have to distribute T to this one. We have to distribute T to the second location, to the third position, before we make the summation. So on the left here, you're going to have 2, 3, 5, and plus 4t minus t, 6t, and closing parentheses like that. And the next step is that you need to combine each component, the first component, the second component, the third component, together, because you have two vectors right at the moment. So we have 2 plus, right? 2, the plus sign, and then 4t. 2 plus 4t as the first component. And the second component is that you start from number 3, and then further we pass the plus symbol, plus sign, and then we go to the second element, which is not positive. So we need to write down parentheses and minus t. Now we finish the second element. Let's talk about the third element. We start with number 5, and we have passed the plus sign, and we passed the 6t. So we have 6t here, and closing parentheses. All right. So you just arrange it a little bit, because we have a plus and parentheses negative t. So finally we have 2 plus 4t, 3 minus t, and 5 plus 6t, and closing parentheses, closing vector parentheses, angle parentheses. So this is the final version of the vector L. That's the outcome, but it's not the final answer, not final solution to this problem, because the line should be written in the set form like this. Okay, that's the set form of what is x to us. This is x for us. This is y for us. This is z for us. Okay, so the ZL. Oh, sorry for that. ZL, the line set will be set of coordinate x, y, and z, given x is equal to 2 plus 4t, and then y is equal to 3 minus t, and then we have z equal to 5 plus 6t, and then you have to say what is t. T is from minus infinity until infinity, and then we close the parentheses. That's the actual answer to this problem. Okay, the line set could be set of x, y, and z. Okay, three things, because we are talking about, we are saying something, we are talking about the three-dimensional space, so there should be three components. Components in the x, y axis, in the y axis, in the z axis. Okay, in the x axis, y axis, and z axis. Three-dimensional space, and what is the value for x? You have to say because, from the outcome here, 2 plus 4t, and y is 3 minus t. Okay, if it's negative, just leave it like that. Okay, if it's positive, we can say it's 3 plus t, but this one is negative, so 3 minus t. And for the z component, it's 5 plus 6t, and t start from negative infinity to infinity. Okay, is it acceptable for you to understand? Okay, I hope it's not too difficult. All right. เข้าใจไหมครับพอได้นะงงไหมมีคนงงไหมครับโอเคเปิดเสียงอะฟังif you are not understand in anything just let me know โอเคไม่เข้าใจตรงไหนถามได้เลยนะครับโอเคไหม just ask me don't worry about it what else there's nothing more, right? Okay. Now when everything is ready, you can understand. We have parsed this topic line through a point and parallel to the vector. We have constructed the line through a point and parallel to the vector like this, and now we the line that we have constructed here could be expressed in you could see that 2 plus 4t, 3 minus t, 5 plus 6t, and the line could be expressed in the three-dimensional system like this one. Okay, this line. This is the outcome for us. Okay, now let's move to the next one, a line through a point parallel to vector, still one. For the above example, the complete form of the line is given by 2 plus 40, 3 minus, this is what I have already expressed it here. Okay, and now there are three, I think, representation of the line in vector form. That's the vector form here. Okay, you express it in the terms of vector L. Okay, you express the line in terms of vector L. The next way is, the second way is, we express the L in terms of parametric form. What is the parametric form? It's the specification for x, y, and z. Okay, it's in the same way. Okay, you know x0, y0, p0 as the point location of the point, and the direction of the vector v is denoted by value a, b, c. So we have three components: component x, component y, component, and component z. And the way you express it, like the x equal x0 plus at, y equal y0 plus bt, z equal to z0 plus ct. This is called parametric form. All right. The vector form is that you express the vector L like this. That's the vector form. Just express the line in vector form, or in the second way, express it in three equations like this. What is the value for x? What is the value for y? What is the value for z? That's known as parametric form. Okay. In the exam, you can choose any form as you want. So let's talk about the line that passes point P 2, 3, 5 and parallel to the vector 4, minus 1, and 6. That's the previous example. That's the previous example, right? The same thing here, right? The question in the in the vector form 2, 3, 5, 4 minus 1, 6, which is the same thing. And in order to express the line in parametric form, you just take only here, okay, 2 plus 4t as x, 3 minus t as y, and 5 minus 6t as z, okay, the third component. And you need to say what is the value for t, and t is any value in the real axis, okay. Now, representation of a line in a symmetric form. Okay, we have three forms. The first form is vector form. The second one is parametric form, which is this one. Right? You have three equations for each component in the XYZ system, right? And for the symmetric form, the way is that you have to express it without t. Okay, without t, symmetric form. Parametric form is the specification for each component in the x, y, and z coordinate. And for the symmetric form, you just arrange this one, okay. Of course, where is that? This one, okay. This is the parametric form. You just change it in terms of t. So we could derive it. Like this. So what is t in this sense? T is going to be x minus 0 divided by a, x minus x0 divided by a. And what is t for y? T is going to be y minus y0 divided by b. And what is t for this? Is t equal z minus z0 by z. Okay, that's the z minus z0 divided by c. These are all t. And in symmetric form, you just make them to be equal to each other. So we're going to have, because everything is equal to t, right? Every term here is equal to t. So we could say, because they are all the same thing, equal to t. So x minus x0 divided by a will be y minus y0 divided by b equal to c. Oh no, z minus z0 divided by d. Okay, and that's the symmetric form. This one is known as a symmetric form. All right. Yeah, the symmetric form is x minus x0 equal to a divided by a equal to y minus y0 divided by b. Oh, sorry, this is not d, is c. Sorry. This is c. Okay, the third one. Yeah. Yes, as you know, the symmetric form is x minus x0 divided by a, y minus y0 by b, z minus z0 divided by c. That's the symmetric form. And the way to express it as in the line set is that you can just leave it like that and say x, y, and z are real value, taken from the real value. Okay. The line set x, the final answer for the line set in symmetric form could be written like this. And for the same problem here, the line that passes the point P and parallel to this vector, what is that in a symmetric form? And of course, we know that we have the symmetric form is that we have x minus x0 divided by a equal to y minus y0 divided by b, and z minus z0 divided by c, right? And you know x0 is 2, y0 is 3, and z0 is 5, a is 4, b is minus 1, z is 6. So if you substitute it into that, x minus 2 divided by 4 equal y minus 3, right? Y minus 3 divided by minus 1, right? Minus 1 here. So equal z minus 5 z minus 5 divided by z, which is number 6. You can also arrange this one here in a better way. Okay, let's say it's equal to 3 minus y divided by 1. But actually, you don't have to write number 1 at all. Okay, you may not need to write number 1 at all. Okay, we don't need that because number 1 has nothing. This is the same thing. Okay. Okay, this is the line in a symmetric form, and if you want to deliver the answer, just leave it inside the set, the line set. Okay, will be a set of coordinate x, y, z, given these. Okay, given this condition, x minus 2 divided by 4 equal 3 minus y equal z minus 5 by 6. And x, y, and z are member of R1 times 1 and closing parenthesis. All right, and that's the way to explain the line set of the point in a three-dimensional system in symmetric form for the lines. Okay, line could be constructed from this set. Okay, please note that we don't talk about a computation 3 plus 4 equals 7. You use that basic knowledge inside this one. Okay, but for us here, we need to express everything in a set form like that. Okay, let's go further now มีคำถามนะครับ if you have any question just let me know. Now we have passed it. Okay, we have finished this topic, line through a point and parallel to vector. Is it okay? Now we will go ahead to the next topic, which is a plane through a point and perpendicular to the vector. This one. We arrive at this one. And let's go further. A plane through a point and perpendicular to the vector. Okay, again, there are three things, sorry. Before we construct the line that passes a point and parallel to the vector, right? But in this case, of course, we have three things. The first one is plane. The second one is point. The third one is the vector. And we are going to construct. We want to construct the plane. You know plane, right? Plane is a smooth planar surface like this. There is no bending. There is no heel. There is no, I don't know, no lifting area at all. Okay, and no bending surface at all. Everything is smooth, and that's the plane, right? This is known as plane. And through a point, right? You know point. Point is anything that has no dimension. This is point. And vector, what is that? Vector is something like this that has direction and magnitude. Vector. Okay, we are gonna build up the plane that passes, okay, or the point should lie on this plane, and this plane should be perpendicular to this vector. Okay, what is the perpendicular vector? For example, if you have a plane like this, and let's say you have this vector and this vector. And this vector, I would say this one, once this one is, let's say phi is equal to 90 degrees, we are not gonna say the vector B. We will not say B if phi, the angle measured from the plane to this vector is not 90, once phi is not 90 degree, we're gonna say vector B is not perpendicular to a plane. Okay, when they find the angle between this vector to the plane is not 90 degrees, we say it's not perpendicular to the plane. But once this vector is made with 90 degree with the plane, let's say when phi is equal to 90 degree, we're gonna say vector A is indeed perpendicular. Vector A is perpendicular to the plane. Okay, now you understand how a vector is perpendicular to the plane, right? The angle that is measured in any direction should be equal to 90. If it's not 90 degree, we will not say that vector is perpendicular to the plane. But if it's measured in any direction and we come up with 90 degrees in every direction, we're gonna say that vector is perpendicular to the plane. Okay, this is the plane green, the green plane. Okay, let's move to the next idea. The way to construct there are polynomial representation. Okay, there is only a single way to express the plane in this level, and the name is known as the polynomial representation of the plane. Okay, polynomial representation of a plane. And let P be a plane in a three-dimensional system. P is a subset. P is a set. Okay, and P contains location x, location y, value z. Okay, in the three-dimensional system, in the Cartesian system. P be the plane in R3. Okay, in a three-dimensional system, and we have x0, y0, z0 as the point P, and point P lies on the plane P. Okay, and n is the normal vector, is non-zero vector, non-zero vector that is perpendicular to the plane P. All right, and we would say that if we want to construct the plane P, we can construct it from the coordinate x, y, z. When this condition holds true, what is that? N is the normal vector which has A, B, C. R is the vector that is known as spanning vector. Spanning vector means you just subtract each component by the point P. Okay, and the dot product is the product to each component, and then you sum up, and the result will be scalar. Is no longer vector. Okay, A dot B will be a scalar, is not vector anymore. Okay, when A has the x component, A has the y component, A has the z component, B has x component, y component, and z component. And A dot B just make the product of each sequence and separated by placing the plus signs. And R is the spanning vector. Spanning vector is made from x minus x0, y minus y0, and z minus z0. All right. when x0 is the point P in the first location, y0 is the value of point P in the second location, z0 is the second component in the point P. Okay, now we the point normal form, this is the point normal form, right? Point normal form is the plane P that characterized by this one. Okay, you just sum of all of them, sum them up and make the equality on the right hand side equal to 0, okay, to be 0, and we get point normal form. All right, and the plane P could be constructed again from this relation, this condition. Okay, now the plane P is okay. You have everything right. L is also set. The line set, it can be written as a coordinate system as well. You can see here. L is a set of x, y, z. Plane P is also the set of x, y, z, coordinate x, y, z. But they have different type of conditions. Here, this is the line, and here is the plane. Okay, for the plane, you just use the point normal form. A, which is the direction of the normal vector n. B is the second component of the normal vector n. C is the third component of normal vector n. You just leave it in front of the parentheses and you subtract the variable x, y, and z by the point P, x0, y0, z0 respectively. And you cascade these three terms by placing the plus signs. And on the right hand side, you just write down equals 0, and that's the point normal form of any plane. Okay? Now let's take a look at the example. It's better to understand by considering an example. In this one, let's open a new page. May I go to the toilet for a while? ขออนุญาตเข้าห้องน้ำนิดนึงนะครับปัสสาวะนิดนึงนะครับ Okay, let's get back in no one more, right? there is no one who would like to write down your name or in either Zoom or YouTube channel, right? Now let me capture your the sound. We should check whether it's well broadcasted or not. Okay. Anything else? Nothing more. Right? Let me check the condition here. Same here is excellent. All right. Yeah. The okay. Same here is fine. Okay. Now we are talking about the point normal form, right, of the plane, right? We want to construct the plane once we know the point and the vector, right? Okay, we have the point P. Okay, the point P. The point P is equal to x0, comma y0, comma z0, and in this scenario it is actually minus 3, comma 1, comma 3. Okay, that's the point P. This is the point. Okay, the first thing that they have provided. The next thing is the vector n. Okay, they have also provided vector n. This is vector n. Vector n, what is that? It is vector that has 2, 4, 8, and this is known as vector. Okay, it's known as vector. You can see that it is written in a different style. The first one, this is the point. It has no direction. We use the curvature parenthesis, and this is the vector. You could see it easily, explicitly, because there is an arrow above this variable, the variable n. It is vector n. There is an arrow, and the parenthesis is different from the curvature one, the circle parenthesis. This is the angle parenthesis. Okay, it's a vector. Okay, please note that they are different either on the left hand side or on the right hand side. Okay, we have two things. We know point and plane. We want to construct the plane. What is plane? Plane is something like this. This is the plane. Okay, this is the plane, and what is that? Okay, this is known as plane. Okay, but the question is that this plane should have the point P on that, and the vector n should perpendicular to this plane. This is vector n. Okay, if you measure this direction, it's 90 degrees. You measure in this direction, it's 90 degrees. If you measure in this direction, it's also 90 degrees to the plane. So the vector n should have 90 degrees to any direction on the plane. Okay, this is the condition we are talking about in this example, this problem. Okay, now it's time to do that, right? Yeah, then point normal form is quite simple. This is A. This corresponds to A, variable A, and this corresponds to variable B and Z, right? And the general form of the point normal, general expression of the point normal form for the plane is that you have A x minus x0 plus b y minus y0 and plus z and z minus z0 equals 0, and that's the point normal form, right? And once you know that x0 is minus 3, y0 is number 1, z0 is number 3, and a is equal to 2, b is equal to 4, c is equal to number 8. So it's not difficult for you at all to construct the point normal form, because you just leave these 6 numbers into this expression, right? So let's do that. A is 2, right? A is 2, so we say this is 2. X is the variable, we have to leave it, okay? We cannot substitute the value for x. X is the variable along the x-axis. x0, what is that? x0 is minus 3. Please pay attention, this is the negative value, it's not positive number. So minus according to this sign, but the value for x0 itself is negative 3. So we have to write down here minus 3, okay, because this is the value for x0. And the closing parenthesis again, closing parenthesis that correspond to this open parenthesis, okay. Now we go to the next one, which is plus and b. Plus, where is the value for b? B is equal to 4, right here. So write down the number 4 and open the parenthesis. Y is the variable along the y-axis. We could not do anything. Just leave like variable y. And y0 is only constant. It's the value from the point P. So y0 is number 1. So minus number 1 and closing parenthesis and plus c. C is the constant that you could find from the normal vector, which is number 8 here. So we write down number 8, and z is the variable, and minus z0. Z0 is equal to 3 right here, so we write down number 3 and equal to 0. Okay, now we finish this equation, and this equation is known as the point normal form for the plane. So but it's not really, yes, because we need to do something here too, right? So yeah, you just arrange it by using simple mathematics skills. So 2 and x, right? And you could combine 2 times of the negative signs here, right? Negative and negative is going to be plus or positive 3, right? And next one you have 4 and then y. Y minus 1, and plus 8 z minus 3 equal to 0. So right, it's not difficult at all. You just combine 2 times of the negative symbol, negative side here, right? It's not difficult. Just write it at a simple positive side, okay? Now you have the final version of the point normal form. This is called point normal form. Point normal form of the plane. This is the plane equation, actually. Okay, this is the point normal form of the plane, but it's not the complete solution. Complete solution of the plane, you have to write out the P, which is the plane, is a set of coordinate x, y, and z. Once x and y and z satisfy or follow this condition, what is that? Just copy it. Okay, copy the point normal form into this set. You have 2 and x plus 3 plus 4y minus 1 plus 8 z minus 3. Okay, and comma. X is a member of R. Y is a member of the real value set. Z also is a member of real value set. And you now can close the whole set. And that's the complete solution for the plane. Because plane is made of points. Okay, plane is a set of points. And the point could be characterized by the point normal form of the plane equation here. All right, It's not difficult, right? And this is the mathematical expression. And if you want to see the realistic vision of that plane, is shown here from the computer graphic. All right, here. The result of that plane in point normal form. Okay, you use computer to plot it. You're gonna get you vary x and y z. You will get this one, which is not surface. Okay, it has no curvature. It's a simple plane. It's planar. It's plane. Okay. Okay, I show you the reality. Is not only the mathematical expression here. But if you put this one into the computer, you will get exactly the plane right here. Okay. Now let's move to the next topic. Okay, we finished this topic. The plane through a point perpendicular to the vector. Okay, the plane that passes the point and perpendicular to the vector, and we represent it in a point normal form, right? We express it in the point normal form. Now we arrive at the next topic, which is distance between a point and a plane. All right. In the previous two topics, we know first point and vector. In the first topic, we construct the line. In the second topic, we construct the plane. But right now, it's different from that. We know the point again. Okay, point is known first. But in this topic, we know the plane. And we want to find the distance between a point to that plane. Okay, it's different. Here we know a point and a vector. And we construct line and a plane later. But in this topic, we know a point, we know a plane, and we want to find the distance between them. Okay, it's different. Is it too difficult for you to understand? ยากเกินไปไหมครับ Is it too difficult? If not, then we could go ahead. I still hope that you still have enough brain power to go ahead. All right. Yeah. There are three things again in this topic. The first thing is the distance. That's what we wanna find. Okay, the first thing is and this is the first quantity. The second quantity is the point, which is this one, and the third one is the plane. Here, three. Yes, there are three things: point, plane, and distance. We know the point. We know the plane, and we want to find the distance between these two things. All right. Q, let's say Q, which is not P, okay? Q is another point. We use the next variable instead of P, okay? It's x0, y0, z0. It's a point P, but we would rather avoid P because it's going to be confused with plane P. Okay, we use the letter Q to represent a point here. Okay, Q is a point. And P with this font is denoted as the plane. Okay, and it's represented in a linear form like this. Okay, it's normal form. This is the normal form because on the right hand side is 0. Okay, point normal form means you don't distribute anything. Okay, this one has been arranged for AX, and we combine all the quantities to this one already. Okay, this one is known as normal form. Okay, now we want to find the distance. Okay, let me draw something first. Okay, let me draw something here. Okay, oh, I forgot to draw. It's no problem. Let's say you know. There is a point Q, sorry. This is the point, and the name of the point is known as Q, and you have a plane like this, a plane, and it's known as plane. And the plane the name for this plane is denoted by plane P. Okay, and you want to find the distance You want to find the distance between this point and this plane, okay? And the way to find the distance, of course, this is also the possible straight line. This is also the possible straight line, right? So what is the actual distance between the point to the plane? You cannot say this one because it's too long. This is also too long. The one that is shortest should be the one that has 90 degrees to that plane. It means the shortest distance between the point to the plane is the way along the vector that is perpendicular to the plane, okay? And that vector will give you the shortest distance between the plane and the point. If you use this root, this vector is not perpendicular to the plane, it's not the shortest one, okay? This root is longer than this root. This root is longer than this root. Because this root is not perpendicular to the plane, okay, it makes some angle. It has some angles to the plane. This one is not the shortest one. It's not perpendicular to the plane. The distance will be the root that is shortest, and that vector should be perpendicular to the plane. Okay, and that's the way. And the formula to find the distance here. Okay, this is the this one. Okay, distance is go along. Distance could be found along this root. Okay, D is from this root, not this one, and not this one. Because they are not the shortest one. Okay, the way to find the distance could be found from this formula: ax0 plus by0 plus cz0 plus d, and take the absolute value for that at the denominator. You know denominator, right? In fraction, fraction or quotient, you have that's numerator. I'm stupid. Numerator and denominator. All right. Fraction has two components. The upper one is known as numerator. ภาษาไทยเรียกว่าเศษ The lower one is known as denominator. ภาษาไทยเรียกว่าส่วน อันนี้เศษส่วน Okay. At the numerator, at the upper part, we have, you just substitute this equation by point Q, x0, y0, z0, and leave it inside the absolute value. You know this bar, right? The bar is the absolute value. For example, if you have negative 3.2, the absolute value for negative 3.2 is going to be only 3.2 without negative symbol, negative sign, right? The fraction could be the substitution of the left hand side by the point Q and leave it inside the absolute value. That's the numerator. But for the denominator, the expression for the distance, right? Distance along distance between the point and the plane. For the denominator, you just take the square root of the first coefficient, which is the number in front of x. The second coefficient, which is the second number, which is the number in front of y. And the third coefficient, which is the number in front of z. Okay, not d, not this constant. We neglect it. We don't use it. We use it only at the numerator. For the denominator, you take the square of the first coefficient, number in front of x. You take the square, okay, power 2, okay, power 2 to the second variable in front of y, and take the square to the coefficient, the third coefficient in front of z. You take the square and then sum them together, okay, cascaded by the plus signs and take the square root. And that's after the division, you're going to have distance between point Q to the plane P. Okay, that's the formula. I hope it's understandable. You can get comprehension to this, right? And now let's talk about the first example. Let's say we have where is that? We have point Q. We have point Q. Where is that? Point Q is 2, 4, minus 5, right? 2, 4, minus 5. Oh, 2, this is the z-axis. This is the x-axis. This is the y-axis. Right? 2 along the x. 1, 2. And 4 along the y, right? 1, 2, 3, 4. And negative 5 along the z-axis. Now we have like this, okay? And we have to go down by 5. And 1, 2, 3, 4, 5. Okay, here, this is the point Q. We have the point Q right there. We know the location of the point Q, which is 2, 4, minus 5. Okay, you have to go along the x-axis by 2 because number 2 is denoted by, it is denoted here. You have to go along the y-axis by 4, 1, 2, 3, 4. And you have to go along the z-axis by negative 5, okay? If it is positive 5, you have to go up because positive z is pointing up. Negative z should go down, okay? The negative quantity along the z-axis should go down from in the opposite direction to this arrow. 1, 2, 3, 4, 5. And here we have point Q. And the plane 5x minus 3y plus z minus 10 is any plane, for example, I don't know how to draw. Let's say this is the plane, 5x minus 3y plus z minus. This is the part 5x minus 3y plus z minus 10 equals 0. Okay, that's the plane, and your task is to find. Your task is to find the distance here. Distance here. What is d? Okay, you need to find the distance between the point Q to that plane. Okay. So the plane is denoted by that one, and what we could do is we use the formula of the distance between the point and plane. Where is that? We are going to use the formula in equation number 25. Okay, d distance from the point Q to the plane P will be the absolute value of a x0, b y0. Too big, I'm sorry for that. The absolute value of a x0 plus b y0 plus c z0 plus d, the absolute value for that, and it's divided by the denominator. The denominator could be found from the square root of the first coefficient square, which is a square, and the second coefficient square, b square, and the last one, the third coefficient square, which is c square only. And now let's get into the detail. Because Q is 2, 4. Q is because Q is equal to 2, 4, minus 5, and it is actually equal to A Oh, sorry. Is equal to x0, y0, and z0, right? And you could see that x0 is equal to 2. You could see that y0 is equal to 4. And you can see that z0 is equal to minus 5, right? And yeah, you know it easily by comparing them together, right? But for the plane P, they have provided the plane P in terms of this equation, right? Plane P is denoted by 5x is normal form, right? Minus 3y plus z minus 10 equals 0, right? And if you compare it to the normal form of the standard plane P, you could see it is ax plus by plus zz plus d equals 0. So now let's compare what is the value for a in this scenario. What is the value for a? And of course you could see a is equal to 5. B is equal to 3 or minus 3. B is equal to 2 minus 3. Okay, please be careful. Otherwise you get something wrong. Okay, you will get the wrong solution to that, which is what I don't want. Okay, I don't want to. I want you to get a full score in any test. Okay, now the next one is C. What is the value for C? Of course, there is no number in front of Z. So what is the value for C? And if you take a close look, there is actually a number which is number 1 here, right? So C is equal to number 1, right? And the last one, what is that? Is the value of D. So D is 10. D is equal to 10 or minus 10. D is equal to 10 or negative 10. It's negative 10, right? Because this is plus minus, right? So D is equal to negative 10. All right, like that. You know A, B, C, D. ผมเริ่มปวดแขนแล้วครับฉีดวัคซีนมาไม่ก็okay, we have got A, B, C, D like that, and we're gonna leave it into this expression D from point Q to plane P, right? So let's go ahead with that by using a good color here. D distance from Q to plane P will be the absolute value A x0. A, what is that? A is 5. X0, what is x0? X0 is number 2 here. And what else? Plus B, y0, plus B, where is B? B is negative 3. And y0 is 4 here. We say 4. And the next one is plus C. C is constant, which is number 1. And the next one is Z0. Where is Z0? Z0 is negative 5. And what else? It's D, plus D. D is negative 10. And we close the absolute value. So that's the whole numerator set นะภาษาไทยนะ set. That's the whole thing in the numerator. Now we move to the denominator ภาษาไทยเรียกว่าส่วนโอเคไหม Now we move to denominator square root. Square root of what? Square root of the first coefficient square. The first coefficient square, the first coefficient is 5, so we have 5 square plus the second coefficient square, which is negative 3. Negative 3 square plus the third coefficient, which is number 1. Okay, number 1. We don't use the fourth one, okay, because the formula has only 3 coefficients. Now let's combine everything by using hand or any calculator as you want, but the first year I think you should use your brain because your brain is still strong. All right. 10, right? 10 for us in 10, you have 10 minus 12, right? And minus 5 and minus 10, right? You can easily use your hand, right? Square root of what? 25 plus 9 plus 1, right? Just combine them, okay? 10 and 10 cancel each other, so it's negative 17. Negative 17 as the numerator. And on the lower part, the denominator, we have 10 and 25, so it's square root 35, right? 35. But please don't leave it like this, because at least you know that the absolute value of negative number will be only the positive part only. So it's equal to 17 divided by square root 35. And if you don't have any calculator, just leave it like that, okay? Then we finish, and this is the solution. The distance between this point to the plane, okay? If you want to find exactly what is that, the distance should be always positive. The distance could not be negative, okay? Leave it into the calculator. 17 by square root 35, what is that? 17 by square root 35. It's 287, okay, approximately 2.87. It's approximately 2.87, okay, and that's it. That's the whole thing. The distance between the point Q to that plane is around 3, okay, 3 units, approximately 3 is 2.87. So the plane, yeah, 2.87 here is the solution, and yeah, this is the plane, and now we finish that topic. We have finished the story about distance between a point and a plane, this topic here. Okay, we arrive at the intersection of two planes. Okay, we arrive at the intersection of two planes. The time still remains for 1 hour, right? Then after that, we are gonna finish this lecture. The remaining time is 1 hour. Okay, let's go ahead with that. We arrive at the topic of intersection of two planes, which is this one. Okay, intersection of two planes. Is there any question from you? Okay, if you have any questions, just let me know. All right. Otherwise, we will go ahead. We will go ahead with that. Okay. Plane, right? Plane is denoted by variable p, and now the story is about two planes. We have two planes, so p, the variable p would have two possible subscripts. Let's say it's p with subscript number 1 and p with subscript number 2. Both are different planes, and yeah, each plane could be described by the set of points, right? Point in three-dimensional system is coordinate x, y, and z, right? And unfortunately, this is the subject of mathematics. Everything should be described by mathematical variables that are variable x, variable y, variable z. Oh yeah, and we can express this plane in terms of this plane as the normal form. This is the normal form. Okay, it's not point normal form. This is the normal form. That's the normal form for us. Okay, and A1, B1, C1, and D1 are the value taken from the real value set. Okay, it's gonna be complex. And for the second plane, it's the set of x, y, and z. And this plane is also represented in normal form too, because on the right hand side of this equality is 0. So it's a normal form. And the coefficient is no longer A1, B1, C1, D1. It should be different because this is the different plane from the former plane. So the first coefficient is denoted by A, but it's no longer with subscript number 1. We're going to have subscript number 2 to denote the second plane. Okay, plane 2 has subscript 2. And for B2, we have B with subscript 2, C with subscript 2, D with subscript 2. Okay. And each value A, B, C, D here with subscript 2 are taken from the real value set here. Okay. Or could be any value along the real axis. That's the whole general description of two planes. Okay. Equation 27A and equation 27B. But our interest in this topic is that what is the outcome of these two planes นะครับไปดูวิดีโอของปีที่แล้วนะถ้าถ่ายทอดกล้องผมจะวาดให้ดูนะมัน3มิตินะครับถ่ายทอดกล้องว่าระนาบมันเป็นยังไงมันมีแบบมี3กรณีนะครับก็คือตัดกันวางห่างกันแล้วก็ซ้อนทับกันสิโอเคไหมครับอันนี้มัน iPad มันจะโชว์ไงดูได้แค่พวก Steam Lab โอเคไหมครับผมอาจจะให้ดูกล้องใน Steam Lab ได้นะครับโอเคไหมbut no one is at the Steam Lab channel so I could not do anything in iPad we could not show that I don't know yeah anyway let's go ahead with that the intersection what is that intersection means it's let's get back to the Venn diagram, right? Intersect theory. Have you ever heard something about a Venn diagram? I don't know how to pronounce it correct properly. Where is that Venn diagram? Yeah, Venn, V-E-N-N. Yeah. Okay. Okay, here. This is the Venn diagram, right? And if we have two sets, set A and set B, and if the set A and the set B have some common elements lying in this area, it's gonna be called the intersection area. Okay, it's like the area that share some common things from both locations. Okay, and here is different from the location here on the yellow area. Oh my god, what happened? มีคนโทรมาครับ why it's just obstruct my hello ครับ hello ครับ oh no stupid okay I'm sorry for that it's stupid phone okay I hope everything is fine right? Oh my god just change the orientation of the camera right? Okay all right okay let's go further now we are talking about an intersection right intersection is the common area that share similar thing from those two groups okay group A and group B all right the intersection for us in the bachelor degree level here is the point x described by location x, location y, and location z in the three-dimensional system. Again, the point here is a member of the intersection of P1 and P2. It means we pick up the point x, y, and z from this area only. We don't pick up x, y, z from this area. We will not pick up x, y, z from this area because it is not common area between those two things. The set x, y, and z that lies in the common area between plane Py and P2 is known as the intersection point of plane P1 and P2. Okay, please remember this. And there will be three possible outcomes from any two planes. The first case is that two planes has the intersection to each other. Let me find any example. Where is here? When the plane intersect to each other, you're gonna get the straight line outcome. Okay, let's say this one here. When this is the first plane, this is the second plane. When two planes are intersecting to each other, the cross-sectional area, which is the touching point of these two planes, will be emerged as a straight line in the yellow here. Okay, that's the outcome, and that's called a straight line. Straight line is a set of points. Okay, if you take a close look, there are many points along the yellow. Okay, it's made of many points. And the outcome of the first case when the plane intersect to each other is the straight line. You cannot get anything else. All right. Let's move to the second case. There's two planes. The two planes lie exactly on the same plane. So two planes are the same thing. What is the case then? Two planes coincident. The two plane coincidence means the two plane coincidence mean you have this. Okay, those two planes are exactly the same plane. If you move them together, they are actually in the same planar. Okay, they are in the same plane. They are similarly planar. Okay, that's the case of coincidence. Okay, coincidence mean, let's see this one. Oh, where is that? No. Okay, here all the three planes are coincident to each other, so they are exactly the same plane. Okay, coincident means in that sense. If you don't completely understand, we may take a look at another figure. Is there any possible figure to that? No, nah? Okay. Yeah. Anywhere else? Maybe here. Yeah, coincident planes mean you have the plane black plane, the red plane. If they are in the same thing, they will locate to each other, coincide to each other. เข้าใจไม่ได้ไหมครับพอเข้าใจไม่ได้งงบอกเลยนะ The third case is that distinction. So two planes will not intersect to each other. Coincident means the intersection is exactly what is the plane there. Okay, the intersection of two planes usually gives you the line in this case, the first case. The second case is that once two planes are the same, so the intersection will be that plane. Distinction are the case when the two planes share nothing together. Okay, distinct. 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 D-I-S-T-I-N-C-T. Distinct build. Okay, when two planes are distinct, right, they are parallel to each other actually. Yeah, when the two planes are parallel to each other like this, in this case, or in any figure like this. When two planes are parallel to each other, please note that if you extend the plane to this direction, extend the lower plane to this direction, there will be no touching point for both planes at all. Okay, they will not reach each other. They will not reach the upper one. The plane M will not reach the plane N at all if you extend it, because they are parallel to each other. They are not in the same location, and there will be no intersection at all. So now we have three cases. Intersection, when the plane intersect each other, we get the straight line. Coincidence mean plane P, plane A and plane 1 and plane 2 intersect to each other and equal to that plane. And distinction means those two planes have no common area at all. So if we write or express it in mathematics, we're going to have P1 intersect P2 equal a line. In the first case, okay, in the second case, P1 intersect P2 equal P2. And in the third case, distinction, P1 intersect P2 equal empty set. Okay, there is no common at all for those two planes. That's distinct case. So now let's go ahead with that. I don't know why I opened this page. Yes. Yeah. So let's make the conclusion. The condition for the two planes to each interact with each other. Oh, each. I don't understand. There's it's typos. Okay, it's typo. I'm gonna remove it. Only one word for each. Okay, two planes. In mathematics, it's P1 intersect P2, right? It's equal to line when two planes are intersecting to each other. And for the coincident case, when the plane lie exactly in the same location, P1 intersect P2 will be P2 or P1. Okay, it's the same thing. And once the two planes are distinct, okay, they are parallel to each other, we'll get the empty set here. One thing. In the section, outcome will be line for the first case, intersecting case. We get a plane for the coincident case, and we get no intersection at all. It's empty set for the distinct case. Okay, you could see the three possible geometrical outcome for these three cases. Okay, but the way how could we observe whether these planes are in this case or whether these two planes lie in this intersecting case, coincident case, or distinct case? That's more important. Okay, that's more important. The way to observe is the following: if they intersect to each other, A, B, C, D, which are the coefficients of the plane in the normal form, are not proportional to each other. It means A in the first plane, B in the first plane, C in the first plane, D in the first plane have no relation to A, B, C, D in the second plane. Okay, and for the coincident case, A, B, C, D are proportional to each other. all of these four terms are proportional to each other, then these two planes are exactly the same plane. They coincide to each other. They just scale by a number. And the third one, distinct. These two planes will have no intersection at all if only ABC. Okay, please note that without D, the constant is not the same. If ABC are proportional to each other for both planes, but D is not, these two planes will be separated, completely separated from each other, or they are parallel to each other. Okay, and let's get into the detail in mathematical derivation. In the intersecting case, we want to solve two equations. A1x, B1y, C1z, D1 equal to 0, right? And for the second plane too, with subscript number 2. There are three unknown variables, right? X, y, and z for these two equations. But we have three unknown variables. We have only two equations, so we're going to solve it. And the outcome should be the straight line. Okay, let's take a look at the first example, this one, and we have plane P1, plane P2 like this. Okay, plane P1, plane P2, and we may arrange plane P1 like this. We're gonna solve this one, right? We're gonna solve this these two equations. Okay, let's do that. Okay, the first plane is P1. You have P1 denoted by minus 2x. This is the short form. Okay, actually it should be written in the set form, but set form is too tedious. Plus 3y plus z plus 6 equals 0. The second plane is P2, and it's equal to 3x minus y plus 2z, and minus 2 equals 0. And we're going to solve these two equations. Let's say this is the first equation, the second equation, and we're going to solve these two equations for x, y, and z. X is unknown, y is unknown, and z is unknown too, right? How could we solve this? There are many ways to solve this, actually. You try to get rid of any variable from these two equations, and that's the way to solve. Okay, one of the things is to make a substitution of any variable that you are interested in. If you are interested in variable z, okay, if you pay attention to variable z only, in equation 1 can be expressed as equation 1 can be expressed as z, right? Z equal to, okay, move everything to the right hand side. You get 2x on the right hand side. You get minus 3y on the right hand side. You move 6 to the right hand side. It's going to be negative 6. Okay, and that's equation number 3. We substitute 3 into equation number 2. And let's see what happens. Okay, wherever you find z, just leave it like this number. And it's 3x minus y plus 2z minus, I'm stupid, sorry for that. 2z, right? So 2z will be replaced by 2x minus 3y minus 6, okay? And the next thing is 2z, and then negative 2, right, equals 0. And then we combine everything. Here we have 3x minus y plus 4x minus 6y minus 12 and minus 2 equals 0. And let's see what is going on with x and y, right? There is only a single term for x, which is only the term 3x. we have only two terms from y, that is negative y and negative 6y. It's negative 7y. We have 4 minus 12 minus 2, so it's negative 14, and plus 4 is negative 10 equals 0. So you end up with a linear equation, a straight line equation, which is 3x minus 7y equal 10. And that's the line equation. It's the equation of the line. Okay, why do we say it's equation of the line? Because if you take a look at the xy plane, 7, 3x, if x is 0, you're gonna have negative 10 by 7, right? Negative 10 by 7. Here is the negative 10 by 7, and if y is 0, you have x 3, so this one. So this is the equation for this. This is the line from this equation. Okay, you just plot this in x and y plane. Okay, you just leave up the z component right here. Okay, z component. So this is a straight line from this equation. So the outcome from these two planes is the straight line, which is denoted by this equation. Okay, so you could see that in the first case, the two planes intersect each other, and the outcome will be straight line. All right. I hope it's not too difficult for you to understand. โอเคผมขออนุญาตเปลี่ยนหูฟังนิดนึงครับมันรำคาญครับหูฟังอันนี้นะครับ Oh my god. Okay, now let's get back. I need to change the headphone because it's not convenient for me to concentrate on. Okay, now we change the headphone. Okay. Test 1, 2, 3. Okay, it's better. Now we move to the second case when two planes coincide exactly to each other. So that means it means this way is better. Okay. It means you two planes coincide exactly to each other, so two planes are the same thing. It means two planes are parallel to each other, and one equation is a multiple of another equation, and the latter one does not provide any additional information. So two planes are exactly the single equation, denoted by a single equation. And once you solve that equation, you get the statement which is true. For example, 0 is equal to 0. Okay, you get that one. And the next feature is that the solution to that to those system equation is infinite. There are many infinite solutions to that. And the number of intersection points is infinite because the solution and the number of solutions is infinite. The intersection of those two planes is the plane. Okay, and now we consider that case. For example, let's take a look at these two planes. We have x minus 2y plus z and plus 1. This is the normal form of the first plane. And here minus 3x plus 6y minus 9z minus 3 equals 0, and that's the second plane. Okay, both are explicit in the normal form because on the right hand side of both equations are 0. Okay, both equations expressed equal to 0, so those are normal form. All right. Now let's observe what is the outcome, because the question here is find the intersection of plane P1 and plane P2. So we need to find that. All right. So let's do that by opening a new page. So equation. Let's use this one. All right. Yeah. We have the first plane, which is denoted by this equation. We have the second plane denoted by this equation. And yeah, we will solve these two equations in the same manner as the former one, the former example. So let's say x. Let's draw it. Okay, we have two equations, right? Just choose any variable that you pay attention, you want to get rid of. Okay, for example, there are many ways to solve this one. Okay, if you are interested in x, for example, you want to get rid of variable x, you may multiply equation 39a by 3. So we're gonna get multiply 39a by 3, for example. Once we multiply equation 39a by 3, we're going to have 3x, right, minus 2y, I'm sorry for that, 6y plus 9z plus 3 equals 0. And in the 30b, we still have the same thing, 3x, 6y, z, and 3 minus 3, right? This is equation, let's say equation 40. And compare it to equation 39b, it's negative 3x plus 6y minus 9z and minus 3 equals 0. That's equation 39b. And if you combine them together, okay, let's say 40 plus equation 40 plus equation 39b, what is the outcome then? So you would get, of course, 3x and negative 3x is going to be 0. And the next one is 6y and minus 6y and plus 6y is going to be are going to be 0, remain 0 too. 9z and negative 9z will remain also 0. Plus 3 and negative 3 will be also 0. And on the right hand side, 0 plus 0 will be 0. So the outcome to this method, to these two equations, will be 0 equals 0. And you get nothing. Okay, you get the true statement. It's correct because the 0 on the left hand side will be equal to 0 on the right hand side. It's nothing wrong. But we don't get any solution for x and y and z. Right, we couldn't do anything. This could happen, and we will conclude that the two planes are coincident to each other. Okay, because we could not get any value for x and y and z. And we get the true statement. The true statement means any x, any y, any z satisfy both equations. So both planes are the same. So we say two planes coincide with each other. With each other, or you can also say that both planes are the same plane. Okay, you can conclude in both methods. Okay, at the same plane, because we get a true statement. Any x, any y, any value for z satisfy both planes. Okay, if you substitute any point x, y, z, it will be valid for both planes. But we will conclude that both planes are the same thing, are the same plane, or two planes coincide with each other. Okay, that's the case. Now let's move to the third case when the two planes are parallel to each other. They don't share anything to each other, which is the parallel version or distinct version, right? What is that? Just take a look here. Okay, they don't share anything. If you extend it extend the plane in any direction, they will not have any intersection point at all. So they are parallel to each other, simply speaking. And in the case of two distinct planes, when the planes are really different from each other, we have this thing. Okay, we have this condition. The planes are parallel to each other. In this case, only A, B. I forget to mention before. Let's get back. I forget to mention. I'm sorry for that. In the first case, okay, you could see that minus 2 to be 3. How could we do it? You have to multiply in order to minus 2 to become number 3. Okay, let's consider the coefficient in front of x. In order to bring minus 2 to number 3, what is that? You have to multiply by minus 1.5. Then you go to 3, right? And what about 3 to minus y? 3, oh, sorry for that. Okay, in order for 3 coefficient in front of y, in order for 3 to become minus 1, how could we do that? You have to multiply it by minus 1 by 3, right? You have to multiply it minus 1 by 3, then you arrive at negative 1, right? n for z, variable z, from 1 to be 2. How could you change number 1 to be number 2? You have to multiply number 1 by 2. Then you get to number 2. Right? And 6 to negative 2. How could we do that? 6 to negative 2. You have to multiply it by minus 1 by 3. Okay, minus 1 by 3. Then you get to number negative 2, right? And you could see that the way to reach the second equation for each component in the first case, the intersecting case, you use for different numbers here, negative 1.5, negative 1 by 3, 1/3, number 2, and negative 1/3. They are quite different from each other, right? And that's why we get an intersecting case, and according to the explanation here, A, B, C, D not proportional, so we use different numbers to convert the coefficient from the first plane to the second plane. And let's consider the coincident case. You have xn negative 3, right? On the first plane, you start from number 1. How could okay, in the first plane you have number 1, and in the second plane you have negative 3. How could we convert number 1 to negative 3? So you have to multiply number 1 by negative 3. So you reach negative 3, right? Easily. Let's consider the coefficient. Coefficient ภาษาไทยเรียกว่าสัมประสิทธิ์นะครับ coefficient in front of y, coefficient of y. So we start from negative 2, and we need to reach number 6. How could we do that? You have to multiply negative 2 by negative 3, right? Negative 3. And then you will reach easily number 6. And let's consider the coefficient in front of z, which is 3 and negative 9. You start from number 3, and you need to end up with negative 9. How could we do that? You have to multiply it by negative 3, and you will reach number negative y. You reach number negative 9 easily, right? And what about the constant without any variable associated with associating with 1 to negative 3? You start from number 1, you have to end up with negative 3. How could we solve that? Yeah, just multiply it by negative 3, and you will reach negative 3. Okay, these two numbers. So in the coincident case, the way to convert the first plane to the second plane is simply by number 1, by multiplying with a single number. So that's the coincident case, but it's different from the intersecting case. You use quite different numbers, okay? Negative 1.5, negative 1/3, negative, oh no, negative, it's number 2, is negative 1/3 again. All right, it's different. And let's consider the third case, which is distinct case. Both planes are parallel to each other. Let's consider the coefficient in front of x in the first plane. It's number 1. Okay, it's number 1. You start from number 1, and you have to end up with number negative 4. How could we convert the number 1 to negative 4? You have to multiply it by negative 4, right? Multiply it by negative 4, and you will reach negative 4. What about the coefficient in front of y? You start from negative 1. You have to end up with number 4. So how could we do that? And again, you multiply it by negative 4 and you will reach 4. Okay? Negative and negative becomes positive. And in the third location, in the coefficient in front of z, it's negative 2 and number 8. You start from number 2 and you need to reach number 8, right? How could we do that? Again, we have to multiply negative 2 by negative 4 and you will reach number 8 easily, right? And the last one is from 1 to negative 3. You start from 1, number 1. Oh, sorry for that. You start from number 1 and you have to reach number negative 3, right? How could we do that? Is it possible to use the same number, exactly same number, negative 4, to convert to negative 3? No, it's not negative 4 anymore. It's different. It is I'm sorry for that. Yellow is not good at all. We're gonna use different number. Is multiplied by negative 3. Then you reach negative 3. So, what is the conclusion then? It means A, coefficient in front of x, B, coefficient in front of y, and C, coefficient in front of z are proportional to each other because they use the same converting number here, negative 4. You convert A to A, B to B, C to C by using only a single number. But when you want to convert D1 to D2, you cannot use the same number, which is the negative 3. It's not negative 4. So in this case, when A, B, C are proportional to each other, but D is not proportional to each other, we're going to say these two planes will lie above each other. These two planes are parallel to each other. These two planes will have no intersecting point to each other at all. Okay, it's different. You just point, you need to notice this difference. For the case of coincidence, you use only a single number to convert the coefficient from one equation to another equation or from one plane to another plane. You use only a single variable, a single number, sorry. But this one, the last one is different. The first three coefficients need only a single number, but for the constant, you need to use a different number. So this means these two planes are distinct. They lie above each other. They are parallel to each other. And for the first case, it's totally different, okay? You use totally different to convert the coefficient in front of x, in front of y, in front of z, and even the constant. Okay, you use totally different numbers. So you can conclude by yourself that you will get the outcome from this case as the straight line. And the straight line that we have derived is this one. Okay, the straight line here as the outcome from the intersection. Okay, we still have 12 minutes more. Okay, ยังเหลือ 12 นาทีนะครับ Okay, let's go further and let's see what happened. Yeah, here you have two equations, and I have introduced you the way how to check whether these two planes are intersecting, coincident, or distinct from each other, right? In this case, it's distinct because the last coefficient could not be converted by the same number. So what is the result then? If you solve these two equations, okay, the detail is the following. Only A, B, C are proportional. As you can see here, you use only a single number, which is negative 4 to convert coefficient A, B, C. Okay, A in front of x, B in front of y. Let me write down. This is the normal form of the plane, right? A in front of x, B in front of y, C in front of z. Only A, B, C could be converted to each other by using a single number. So we say A, B, C are proportional to each other. A, B, C are proportional from one plane to another plane. And D is not proportional because we cannot convert D by using the same number, -4. It's different. So if you solve this equation, these two equations, you get the wrong statement. What is the wrong statement? The untrue statement, the statement which is not true. The true statement is, for example, you get 0 equal to 0, you get 1 equal to 1, you get -1 equal to -1. So those are called true statements. But the false statement is like you get 0 equal to 1, which is not true at all. You try to force something to be equal to each other, but you end up with something which is not valid. It means those two equations have no share point, no sharing point, no similar points at all. Okay? And it means there is no solution to this system equation. If you solve these two equations, there is no solution for them. Okay? Because those two planes are parallel to each other, they don't touch each other, they have no common point. And the number of intersecting points is 0. There is no intersecting point at all. There is no point for the intersection result. Okay, that's the whole thing for the distinct planes. And let's solve this equation and see what's happening. Okay, we have this equation, and what variable you want to get rid of. Let's say if you multiply the first equation by 4, let's say 45 I don't like this color because it's too light. It's difficult to see. Okay. 45a multiplied by, for example, if 4, okay, by 4 we get where is that? It's darker. 4x, okay, 4x minus 4y minus 8z minus plus 4 equals 0. Okay, and say this is equation I don't know, 45c. And let's compare to 45b. 45b says minus 4x plus 4y. Sorry for that. You need to use different color for better. Okay, 45b is minus 4x plus 4y and plus 8z and -3 equals 0, right? That's equation 45b. We write down it again. Now we combine, let's say 45c plus 45b. What is the outcome? Okay, to combine them, you get 4x and minus 4x. What is that? It's 0, right? 0 minus 4y and 4y. What is that? It's plus 0. Minus AZ and plus AZ, what is that? It's 0. 4 and minus 3, what is that? You get number 1, right? This is plus 1. And on the right hand side, you combine 0 to another 0. What is that? 0 plus 0 is going to be 0. So on the left hand side, we have 1. And on the right hand side, we 0. So it's wrong. It's the wrong statement. It's a false statement. It's wrong. Unfortunately, it's not correct. So once we try to force these two planes to be equal to each other, it's not true at all. So it means both planes are parallel to each other, because there is no intersecting point at all to each other, because there is no intersecting point. section point from both plane. Okay, that's the conclusion from this case. Okay, I have showed you the third case, right? For the three possibilities of the planes. Once we want to observe whether they intersect each other or not, right? Now we move to the next thing. We arrive at, before we reach the last topic, which is surface intersecting of two planes. Okay, we still have three more examples. So find the intersection of plane P1, which is denoted by this equation and this equation, and the next example is intersection of this plane, and this plane. Okay. If you understand, anyone in Zoom, I think anyone in Zoom เหลืออยู่ไหมครับเหลืออยู่นะ apart from me you are 10 people here right คนไหนตอบได้บ้างถ้าเรียนรู้เรื่อง50คู่นี้เป็นแบบตัดกันหรือว่าทับกันสนิทหรือว่าวางห่างๆขนานกันเป็นกรณีไหนครับ There are three possible cases. The first case is I'm sorry, I'm going to use a different. Okay, no. I know which. This one. Okay. The first case is in the secting. They intersect each other. The second case is they coincident. Okay, มันทับกันสนิทนะครับ coincident. The third case is they are parallel to the no intersection. They are distinct from each other. So, what is the case for the first pair? Equation 50A and 50B. มีคนไหนตอบได้ไหมครับคนอยู่ที่ Zoom ตอบก็ได้นะคนอยู่ที่ YouTube ตอบก็ได้นะเดี๋ยวเราจะจบกันแล้วนะครับช่วยคิดหน่อยว่า 50A 50B เนี่ยมันตัดกันแบบไหนตัดแบบกรณีที่1กรณีที่2หรือกรณีที่3ครับPlease help me. I think you still alive, right? I'm gonna capture your name list who are in YouTube and send it to you in the group line, the line group. Help me, please. These two planes are intersecting to each other, or coincident to each other, or distinct from each other. 1 or 2 or 3. And this one, 51A, 51B. These two planes are intersecting to each other. They have intersecting points, or coincident to each other, or distinct from each other. And this one, these two planes are intersecting to each other, coincident to each other, or distinct from each other. Tell me, please. ชัยกิจแจ๊บ438 2หมายความว่า50นี่ตอบ2ใช่ไหมหรือว่าไงครับเปิดไมค์ตอบได้นะ Help me please ชัยสิทธิ์ say 50 coincident to each other I don't know what technique you want to use to observe but ชัยกิจ2ใช่ครับOkay, yeah. He said these two planes are coincident to each other. They are exactly the same thing. He said. Anyone agree with him? Anyone agree with him? I would say let's get back to our story. The two planes will coincident to each other, will be exactly the same thing if we use only a single number to convert one plane to another plane, one coefficient to another one. We use a single number like -3 for this case, and we end up with another plane easily. So we start from the first plane. What number we could use to convert 50A to 50B? We simply use number 2. Okay, you multiply the first plane by number 2, you will get plane number. You multiply plane number 1 by 2, you will get plane number 2. Okay, เอาสมการที่1คูณกับ2นะครับคุณจะได้สมการอันล่างเห็นไหม Okay, once you use only a single variable to convert from one plane to one plane, from one plane, and you will get another plane. It means you have the coincident case. Both planes are exactly the same plane. Okay, let's talk about this one. 51. อาจจะหมดเวลาเลยเวลาแล้ว51. What is that? 1, 2, 3. มีแค่3กรณีนะครับไม่มี choice 4. โอเคครับ We have only 3 possible cases. This one is, this problem is intersecting, coincident, or distinct. Help me please. ชัยคิดอีกแล้วคนอื่นไม่ตอบเลยเหรอคนอื่นทำไม่ได้หรือว่าอย่างไรครับคนอื่นทราบไหมชัยคิดแล้ว he said number 3เขาอาจจะเก่งคณิตศาสตร์นะคนนี้ชัยคิดนะชัยคิด said number 3. What is that? The case when two planes are different from each other, they are parallel to each other. So we can use only a single number to the first 3 coefficients. So from 3 to 2, what is that? How we convert 3 to 2? If you start from 3 and you need to end up with the number 2, what is that? You have to multiply it by 2 by 3, right? You have to multiply it by using 2 by 3. Then you will end up with number 2 easily. And from 6 to 4, 6 to 4, what is that? You have to multiply it by, again, 2 by 3. And you will end up with number 4. And if you start from number -9, and you need to end up with -6, you have to multiply it by, again, 2 by 3. You will get -6. And what about -3 to -4? -3 to -4. You can't use 2 by 3 anymore. You have to use something else, and that's 4 by 3. You will reach -4. Okay. Once the first 3 can be converted to another plane, but the last one cannot be converted, it's gonna be the third case, which is distinct. Okay, this one is known as distinct. The third case. They are parallel to each other, and here is coincident, right? Coincident. Okay, and let's talk about the third one, the third problem. We will leave this lecture soon. 52. What is the answer to this one? Intersecting, coincident, or distinct? This one. Chaya kid again. He said the first case. All right, clever. He said both planes intersecting to each other. Let's talk about it. We start from 1, right? 1, 2, 3. we start from 1, we need to end up with number 3. How we convert it? You need to multiply it by 3. You will get number 3. Right? The second coefficient for y in front of y is number 2 to number 2. So you start from 2 to number 2. No, it's impossible. You have to multiply it by 1. You cannot use the same number, which is number 3. Okay, you just use only number 1. To become 2, you have to multiply by only number 1. What about coefficient in front of z? Actually, you can stop already, and you can say the intersecting of these two planes will be a line, and then you start to solve these two equations to find the line equation. You start from 3, right? Coefficient for z, and you need to end up with number 1. How we convert number 3 to number 1? You have to multiply it by 1 by 3, and yeah, you could see that they are totally different. Number 3, number 1, and 1/3. Let's check the last one. We start from 1 to number 2. You start from 1 and you have to reach number 2. How could we convert it? We have to multiply it by number 2, right? And we end up with number 2. So you could see that 3, 1, 1/3, and number 2 are totally different. So the case for this one will be intersecting, right? Intersecting. Okay. So that's the whole lecture for today, and we will continue. Thank you very much ชัยกิจขอบคุณมากครับชัยกิจนะครับปรบมือให้นะโอเคมากขอบคุณมากที่ตอบได้ทั้ง3ข้อคนอื่นผมเดาว่ารู้เรื่องนะโอเคไหมข้อสอบก็จะออกประมาณนี้แหละนะเช็คให้คุณเช็คเฉยๆว่ากรณีไหนแล้วก็ถ้ามันตัดคุณต้องแก้สมการหาออกมานะหาออกมาว่าเส้นตรงที่ได้เส้นตรงอย่างไรโอเค we will stop which is in the same speed as the last year โอเคปีที่แล้วรุ่นพี่คุณก็จบประมาณนี้นะครับครั้งแรกเลคเชอร์ไม่ใช่เลคเชอร์ครั้งที่แรกครั้งแรกเลคเชอร์ครั้งที่2แต่ขึ้นเนื้อหาจริงๆครั้งแรกนะครับก็จะจบตรงนี้แล้ว surface ก็จับไปว่ากันครั้งหน้าโอเค we need to stop our lecture today but I need to ask you for the homework okay it's time for you really to start the homework right now because you have sufficient knowledge. Choose any problem that took place in this lecture to be your homework นะครับเลือกปัญหาใดก็ได้ที่คุณเรียนในเรื่องนี้แล้วคุณรู้เรื่องยกอย่างเช่นคุณไปหาระนาบ2อันมาอย่างนี้ก็ได้ P1 P2 แต่ห้ามลอกในเลคเชอร์นะครับคุณไปเปลี่ยนเลขเอานิดๆหน่อยๆได้หมดโอเคไหมแล้วคุณก็แสดงวิธีทำมาว่ามันออกมาเป็นอาการไหนมันเป็นแบบตัดกันมันวางทับกันสนิทหรือว่ามันห่างแตกต่างมันวางขนานกันกรณีที่3แสดงวิธีทำมานะครับไม่ใช่เขียนลอก2ระนาบมาแล้วตอบปึ้งเลยไม่แสดงวิธีทำผมตัดคะแนนนะใครทำไม่สมบูรณ์ได้ 0.75 นะครับ 3.4 นะครับถ้าคุณสนใจเรื่องระนาบตัดกันนะสำหรับคนที่เรียนไม่รู้เรื่องระนาบตัดกันคุณก็ไปหาเรื่องอื่นเช่นหาระยะห่างระหว่างจุดและระนาบโอเค you can also find any homework about the distance between a point and a plane ก็ไปเลือกระนาบเลือกจุดมาแล้วก็ใช้สูตร25นะครับถ้าคุณชอบหาคิดคำนวณแบบออกมาเป็นตัวเลขเป๊ะๆอย่างเงี้ยหรือถ้าใครเรียนไม่รู้เรื่องนะครับอยากไปหาระนาบสมการระนาบคุณก็ไปตั้งโจทย์มาคล้ายๆอย่างเงี้ยให้หาสมการระนาบในรูป point normal form นะครับโดยที่ผ่านจุดนี้แล้วก็ตั้งฉากกับเวกเตอร์อันนี้โจทย์ใดก็ได้นะครับที่เป็นสีน้ำเงินเนี่ยโอเคไหมแต่ว่าห้ามลอกเหมือนเป๊ะกับในเลคเชอร์ถ้าใครทำเหมือนเป๊ะผมตัดคะแนนนะครับโอเคไหมถือว่าคุณไปลอกตัวหนังสือคุณไม่ได้คิดเองอะไรเลยนะครับ and what else or you may find the line หรือว่าถ้าใครสนใจหาเส้นตรงนะครับสมการเส้นตรงที่ผ่านจุดแล้วก็ขนานเวกเตอร์ก็ไปหาพวกนี้มามี3ฟอร์มนะฟอร์ม Parametric Form เอาอันเดียวนะไม่ต้องทำ3อันนะคุณไม่ต้องทำเยอะผมขี้เกียจตรวจครับ แค่ที่ให้มีการบ้านเนี่ยคืออยากให้ช่วยคุณไม่อยากให้คุณติด E แค่นั้นเองครับมี3ฟอร์มนะครับฟอร์มแรกก็คือ Parametric Form Vector Form แล้วก็มี Parametric Form Vector Form แล้วก็Symmetric Form 3ฟอร์มคุณไปเลือกเอาฟอร์มใดฟอร์มหนึ่งนะหาสมการเส้นตรงในรูป Parametric Form Vector Form Symmetric Form คุณไปเลือกเอาแล้วก็มีเท่านี้โอเคไหมครับ Choice ในการเลือกทางบ้านมีอยู่แค่นี้นะครับก็คือหาสมการของลายเส้นตรงเขียนอยู่ในรูปเซตนะครับคุณต้องตอบอยู่ในรูปเซตนะรูปเซตก็คือรูปเซตแบบนี้ L เซต L point x y z x เท่ากับเท่าไหร่ว่าไป y เท่ากับเท่าไหร่ว่าไป z เท่ากับเท่าไหร่ว่าไป t เป็นยังไงนะครับถ้าเป็น symmetric มันจะไม่มี t นะครับโอเคไหม symmetric มันจะเป็นแบบเนี้ยไม่ติด t แต่จะติด x y z แทนโอเคครับสมการเส้นตรงได้หรือถ้าใครสนใจจะหาระนาบคุณก็ต้องไปตั้งเซต p หาเขียนอยู่ในรูปของ point normal form แล้วก็ขึ้นรูปเซต p แล้วก็ตอบมาเป็นเซต p รุ่นพี่ก็ทำมาอย่างนี้ครับโอเคไหมเนี่ยแล้วคุณก็ตอบแบบนี้ต้องตอบแบบสมบูรณ์แบบนี้นะโอเคwhat else เส้นตรงระนาบได้นะครับแล้วก็หา distance ก็ได้นะมีประมาณ4ปัญหาคุณเลือกเอาแค่อันเดียวนะครับส่วนเส้นตรงมันมี3ฟอร์ม Parametric Form Vector Form Symmetric Form เอาแค่ฟอร์มเดียวรุ่นพี่คุณทำมา3ฟอร์มเดี๋ยวผมตัดคะแนนนะทำมาเยอะผมขี้เกียจตรวจครับแล้วก็เอาแค่ฟอร์มเดียวเท่านั้นเอาที่คุณรู้เรื่องหรือปัญหาระนาบตัดกันก็ได้นะครับแต่คุณต้องแสดงวิธีทำนะว่ามันทับกันเพราะอะไรมันแยกออกจากกันเพราะอะไรมันตัดกันเป็นเส้นตรงเพราะอะไรแล้วก็ถ้ามันตัดกันถ้ามันตัดกัน intersecting case คุณต้องหานะว่ามันตอบออกมาสมการเส้นตรงที่ผลจากการตัดเป็นอย่างไรคุณต้องตอบเนี่ยก็คือแก้สมการแล้วก็ได้สมการกี่ x บวก y เท่ากับอะไรก็ว่ากันไปเนี่ยคือสมการเส้นตรงที่เกิดจากผลของการตัดกันของสองระนาบคุณต้องตอบนะถ้ามันตัดกันไม่ใช่บอกว่าตอบว่ามันตัดกันแล้วไม่หาผลการตัดที่เป็นเส้นตรงผมก็ตัดคะแนนนะครับโอเคไหมถ้าใครไม่ตัดก็ไม่ตัดก็ไม่ต้องหาโอเคไหมครับถ้าระนาบมันไม่ตัดก็ทำไงได้ธรรมชาติมันไม่ตัดหรือว่าถ้าระนาบมันทับกันคุณก็ไม่ต้องหาโอเคไหมคุณก็ไม่ต้องหาผลการตัดเพราะมันทับกันเนี่ยโอเคไหมก็คือมันเซตมันคือตรงนั้นเลยนะครับ where is that here โอเคนะครับถ้าใครสนใจระนาบตัดกันก็ไปเลือกปัญหานี้ทำมาแค่เรื่องเดียวห้ามเกิน2แผ่นA4 นะครับเดี๋ยว create ให้ใน Google Classroom นะครับ homework submit homework โอเค if you have any question just let me know มีปัญหาอื่นใดโปรดเปิดไมค์ถามพิมพ์มานะครับ if not we are gonna quit our lecture today thank you very much see you next Thursday right bye bye ครับสวัสดีครับ